Welcome. Have you ever looked at a GCSE exam question and just wondered, what on earth does the examiner actually want from me? Well, in this explainer, we're going to crack that code. We are taking apart a real AQA GCSE Chemistry question piece by piece to show you exactly how to lock in every single mark.
And our guide for this little mission? It's the official AQA mark scheme. You see, our goal isn't just about finding the right answers. It's about building the right way of thinking. By the time we're done here, you'll be able to look at these questions through the eyes of an examiner, totally ready to score full marks.
All right, so here's our game plan for tackling question 5. First, we'll decode what the question is even asking. Then, we'll get into weak acids and concentration, and jump into the practical side of things with indicators. After that, it's the big one, the titration calculation, before we wrap things up with pH and electron structures. Sound good? Let's get started.
Okay, first things first. Let's just break this question down. We're going all in on question 5 because, honestly, it's a perfect example. It's all about acids and alkalis, which is a huge topic, and it tests a whole range of your chemistry skills, from just remembering facts to doing some pretty chunky calculations.
So let's kick off with the first two parts of the question. Now, these are all about your fundamental definitions and your understanding of concentration. They might seem easy, but trust me, the marks are always in the little details. Right, first up, a classic one-mark definition question. What is a weak acid? But hang on, look really closely at that last bit. In terms of ionization. That's not just a friendly suggestion. Nope, that is a direct order from the examiner telling you exactly what your answer has to be about.
And boom, here's the perfect answer, taken straight from the mark scheme. A weak acid is partially ionized in aqueous solution. Now, you might get away with saying something like it doesn't fully ionize, but using that precise scientific term, partially, that's the language examiners love. That's how you guarantee you get that mark.
Next, we've got a multiple-choice question on concentration. Really, all it's asking is, how do you make a solution stronger or more concentrated? To figure this out, you got to think about the two main ingredients, how much stuff you're dissolving and how much liquid you're dissolving it in.
So what it really boils down to is this. You want more stuff, that's the mass of the acid, in less space. That's the volume of the solution. So doubling the acid while you have the volume, that's going to have the biggest possible effect. And the mark scheme confirms that's the only right answer.
Okay, let's switch gears and talk about choosing an indicator. This part is all about your practical knowledge from the lab. Do you remember the right tools for a titration and the chemistry that makes them work? Let's see. Now this is a classic 2-mark question. It's a linked pair. You get 1 mark for naming a good indicator and the second mark for getting the color change right for that specific one. You can't mix and match here. They have to go together.
And this is a perfect example of how the mark scheme often gives you choices. You could have gone with methyl orange, saying it goes from yellow to red, or maybe phenolphthalein, going from pink to colorless. Even litmus would have worked. The point is, any one of these complete pairs would have bagged you the full 2 marks.
Okay, a quick-fire recall question now for 1 mark. This is pure memory. What's the chemical ion that's responsible for making a solution alkaline?
And there you have it, O-, the hydroxide ion. Notice the little details, though. You need the right capital letters, O and H, and that little negative sign for the charge. That level of precision is exactly what gets you the mark.
And now, for the main event of question 5, the 5-mark calculation. I know this is the part where a lot of people start to sweat, but there's really no need. It's just a process, and as long as you show you're working, you can pick up marks along the way, even if you make a little mistake at the end. We're going to break it down step by step.
Okay, so first things first, let's pull out all the numbers we're given. We've got the volume and concentration for the sodium carbonate, and we've got the volume for the nitric acid. Our job is to find the concentration of that acid. And the key that unlocks this whole puzzle, it's the balanced chemical equation that connects these two chemicals.
So if we follow the mark scheme, it's a super logical 3-step journey. First, you calculate the moles of the stuff you know everything about, in this case, the sodium carbonate. Second, you use the mole ratio from the big balanced equation to figure out the moles of your unknown, the nitric acid. And third, you just plug the moles you just found and the volume into your concentration equation.
And once you run the numbers through those 3 steps, and this is absolutely crucial, you round it to 3 significant figures like the question asked, you land on your final answer, 0.263 mole per decimeter cubed. And that's how you nail all 5 marks.
But here's a really important exam tip for you. We just walked through the standard 3-step method, right? But the AQA mark scheme itself actually shows that there are other ways to get the right answer, like using a single big algebraic formula. The big takeaway here is this. As long as your method makes sense and your working out is clear, the examiner will give you the marks. There's more than one road to the right answer.
All right, let's finish this off and tackle the last 2 single-mark questions. These are quick-fire questions that test totally different bits of your chemistry knowledge, jumping from the pH scale all the way over to atomic structure.
So this question is all about the pH scale. And here's the thing you have to remember. It's not a simple number line. It's logarithmic. All that means is that for every one step you go down the pH scale, the acidity actually jumps up by 10 times. So the question is, what happens when the pH drops by 2 whole units, from 4.5 down to 2.5?
And here's the rule of thumb you just have to know. A pH drop of 1 is a 10 times increase in H+ concentration. So because our pH drops by 2, that's a 10 times 10, which is a 100 times increase. So all we do is multiply the original concentration by 100, and that gives us 3.16 times 10 to the minus 3.
And for our very last mark, we've got a little electron structure puzzle. We're starting with a chloride ion. That's Cl-. That little minus sign is the clue. It tells us it's gained 1 electron compared to a normal chlorine atom. So the question is, which neutral atom on the periodic table has that exact same number of electrons?
And the answer is argon. Let's just think that through. A normal neutral chlorine atom has 17 protons, so it has 17 electrons. The chloride ion, Cl-, has gained 1 extra, bringing its total up to 18 electrons. So we just look at our periodic table, find the neutral atom with 18 electrons, and yep, that's argon. So let's wrap this all up. What's our exam strategy? Use precise language. Show every single step of your calculations. Always double-check your mole ratios from the equation, and pay attention to significant figures. But you know what the real takeaway is? Cracking an exam isn't just about knowing chemistry, it's about understanding the game and giving the examiner exactly what they're looking for, mark by mark.